Okay, so.
Okay, sorry, I'm just making sure. 11.3 is the only thing I still need some help with. So, anything else, I'll just turn it.
So, imagine you're going on a trip to Paris.
I've never been to Paris. Have you been to Paris?
Yes.
I feel like you've been
I've
to
been
Paris.
to Paris.
Yeah. I studied in Paris. Have you been to Paris, Jonathan?
I love it.
I was really studying in the south of France, but I spent 2 weeks in Paris studying. Okay. So, imagine you're going on a trip to Paris. Here's your suitcase. You're packing. You have 5 shirts, 3 pants, and 4 pairs of shoes. You want to make sure that you have enough variety of outfits. So how do you figure out how many outfits you have total from these outfit ingredients? So, say you have 5 shirts, right? 1, 2, 3, 4, 5. 5 different options for your shirts. So then, these are your shirts. Then for every shirt that you wear, you have 3 options for pants. Make sense?
Mm-hmm.
So far, just combining shirts and pants, you would have this many option
3
outfits.
times 5.
Exactly. And then for each combination of 1 shirt and 1 pair of pants, then you have 4 pairs of shoes from there.
That's a lot of shoes. It looks like one of those little flowers. With a bunch at the top. I don't know. Or like the structure of like baby's breath flowers.
Oh.
A little bit.
Yes, I agree. So, if we wanted to know how many outfits total we could make, we could count up each one of these branches.
Mm-hmm.
But as you already said, it's much faster if we just multiply them together. So that becomes 15 times 4, which is 60.
Yeah.
So you can have 60 different outfits out of your suitcase.
That's pretty good.
Yeah. Does this make sense?
Yeah.
Okay. This is called the fundamental counting principle, because we could have counted.
Mm-hmm.
And the principle states we could just multiply the options together instead. And this only has to do if we are trying to find how many different ways we can pick one of each. Does that make sense? There's lots of word problems that are things like you go to the deli and you have 4 options for bread and 5 options for meat and then 4 options for cheese and 2 options for chips. How many total different orders could you make? You just multiply everything together.
Right.
Good. I'm glad that this is not confusing.
Finally, a concept. It's like good.
So, now we're going to talk about permutations. Okay? Say goodbye to my Paris drawing. It's beautiful.
Oh.
You worked so
Can you
long on that.
just erase the stuff around it? Just keep the picture.
I even kind of like the suitcase. I think it looks pretty good.
Yeah, the suitcase. Keep the suitcase. Just
Okay.
here it is. The baby's breath. Goodbye.
Go. Okay.
Great. I love it.
You like my baguette?
Yes.
All right.
What's the little dot on his head though?
That's a beret, and that's his eye.
Oh, that's his eye.
Oh my gosh.
I
I thought his
he was looking
mustache was
down.
his eyes.
Oh.
Now I see it. though.
Here.
And his little goatee was his,
It looks like he's looking down. There you go.
Just like covering his eye.
Yeah.
Okay.
That's cute.
So now we're going to talk about something called a permutation. The idea behind a permutation is that you have like so many slots. Okay?
Oh, are you recording this?
Yep.
Okay.
So
Sure.
you have so many slots.
Uh-huh.
And you have a big group that you could choose from
Oh, I see.
in order to put here. But the idea is that you can only choose one that goes here a different one that goes here,
Oh,
and then a different one that goes here.
Yeah.
So, say there are 10 runners in a race, okay? 10. There are 3 winners, first, second, and third place. First, second, and third place. How many different runners could score first?
10.
Exactly. And then for each one of those 10, we have a different option about who would be second. So we end up multiplying.
9.
Right, then there are 9 runners left who could score there. And then how many could score third?
8.
Exactly. 8. Does this make sense?
Mm-hmm.
Okay.
But you could also go the opposite way too and say how many would be last.
Right.
And then how many would. Right.
Yes.
Okay.
So in order to solve a permutation, it's helpful to think of it as you're finding out not only how many possibilities are there that there are 3 winners, because if we're finding out how many possibilities that there are 3 winners, then that's how many different ways can you make 3 out of 10 different people. Does that make sense?
I think so.
But within that 3 that we've chosen, how many can be in each spot?
Okay. Basically, you're finding a new probability for each spot because it changes every time based on the previous.
Right. If we were only choosing how many different ways we could choose, like say you still have 10 runners and there are 3 winners, and we're just choosing how many different ways we could pick, or how many different options there are for the winners. So we're not differentiating among first, second, or third place, just the top 3, like the top 3 move on to the next final.
Mm-hmm.
So how many different ways are there for 3 players to advance out of the 10? So this is a formula. And that formula is going to be 10 factorial. I'm going to go over what that means in a second.
Oh, I remember this from the other. Okay, I know. Yeah.
So 7 factorial, that's how many people are not chosen, or do not advance. 3 factorial is how many people do advance. This is called a combination. So this one is the combination. Now, the permutation is similar to the combination because we're still finding a group of 3 out of the 10, right? But within every group of 3 that we're selected, there's a different number of possibilities of how those 3 could be arranged. So, the formula for a permutation, we would expect it to look similar to a combination, but it has just a little bit more involved. So, the formula for permutation would then be 10 factorial over 7 minus 3 factorial. Or 10 minus 3. Excuse me.
Is this just for this particular problem? Or
No, this is the pattern.
it's always going to be 10. And
No. Yes.
Yeah.
I'm sorry. I didn't
okay.
understand what you said.
Yeah.
Yes.
Okay.
Just because we chose 10 and 3, those are the numbers we're working with.
Right. Okay.
So this is 7 because that's 10 minus 3.
Okay.
Okay. And then this simplifies to 7 on the bottom.
Uh-huh.
So there are fewer possible results from a combination than there are from a permutation. And that makes sense because we're dividing by a larger number in the combination.
Mm-hmm.
Or dividing by a smaller number, the answer is bigger. So this is a permutation. Permutation, combination. Okay. Now, in your calculator, you're going to use a very specific button. And that button for permutation is going to look like this. And for combination, it looks like this. And I'm going to tell you where it is. This means permutation. This means combination.
Okay.
So for permutation, n is how many things there are to choose from. So in this case, it would be 10. P, and then R is still how many places like we are choosing them for. So in this case, it's 3.
And 3 is
How many places, how many like
places.
winners there are.
Right.
And then here, it's still set up the same way, but we tend to say 10 choose 3.
okay. That makes sense.
There's not really a little phrase that we use to say this. We would just say like 10p3 or something like that.
3.
Yeah, it's different for a permutation. Okay. So far, everything is okay?
I
Does
think
this
so.
make sense?
But what's the difference between combination and permutation?
The difference is that for a combination, you're just picking how many ways can I make a group of 3
Oh.
out of 10.
And combination is
And permutation
permutations. Okay.
has a combination in it. How many ways can I pick 3 out of 10? But then also combined with that, how many ways can I arrange those 3?
Okay.
So when we're talking about permutations, the phrase order is important is often used. If it matters, if there's a difference between being selected first or second, or if like there are elections and we're voting for president, vice president, and secretary, it's not just that you got elected, it's that you got elected specifically as president. There's a difference among the electors or electees. That's permutation. Permutation is a lot more specific than combination is.
Okay. I have a thing where they gave me the a sub 5 and the a sub 15.
So you have to plug in 5 for n and whatever a sub 5 is for a sub n into that formula. A sub n equals a sub 1 plus n minus 1 times d. Other page. Yeah. And then you're going to do the same thing with 15 for n and whatever a sub 15 is for a sub n. You're going to come up with a system of 2 equations, and then you can solve either by substitution or elimination.
What? So you plug it into here, into n, and this. Twice, though.
You do it 2 different times.
2 different times.
Okay, so far so good?
Yep.
Okay. So let's do an example, other than the example that I just used to teach. Okay.
Still reading?
It was just a second ago. I think it is just very lightly. So
Okay.
you'll see
I
it.
love this weather so much.
I do
This
too.
is my favorite kind of weather.
I want to live in England where it does this all the time.
Wow.
Okay.
I like it for a little bit, and then I like the sun.
So, like example 4 says you are considering 10 different colleges. Before you decide to apply to the colleges, you want to visit some or all of them. In how many orders can you visit 6 of the colleges and 10 of the colleges? So you're planning a trip. You're going to go visit potential colleges. There's 10 you want to go to. Your first option is, well, maybe I won't be able to go to all 10. So say I pick my just top 6. How many ways are there for me to pick my top 6?
Right.
And-
so it doesn't matter the order, so you would use combination.
Right.
Okay.
But if you wanted to say, okay, I'm like actually planning my itinerary for the trip. How many different ways can I plan my trip? Like, that's my phone ringing.
Okay.
So that on day 1 you go to this college, on day 2 you go to this different college.
Mhm.
You're not going to repeat anything right now like that. So that one would be a permutation.
Okay.
So for just how many different colleges can you visit, that's this. If you can only go to 6.
10 and then you choose the 6. Okay.
Right. And if you're talking about how many different ways can you plan your trip to visit them, one on each day, it's this.
Okay.
Okay? And then if you wanted to say how many different ways can you, like, so say you're doing this, and let's go over how to punch that into the calculator. So from the home screen, press Math.
Mm-hmm.
And this is actually under the Probability tab.
Okay. That makes sense. Oh, I see it. Okay.
So let's do permutation first.
Okay.
So press Enter. Oops. I pressed too soon. Okay. And then
where'd it go? We go back. Okay.
Enter. Yeah. So then for your calculator, which is different. Oh. Here's what you have to do for yours. You have to put the number 10 in front of it.
Okay, so put 10 first and then go to
Yeah.
Okay, that's what I thought because it had the. I was like, okay.
And then you'll press 6.
6 and then enter.
Uh-huh.
Whoa. Okay, so there's a lot of options.
And expect big numbers. Don't be thrown off by big numbers.
Okay.
Because if you think about it, what we're doing is 10 times 9 times 8 times 7 times 6 times 5. 1, 2,
Right.
3, 4, 5, 6. That will be a big number.
Because it would be 10 minus 6.
Right, it'd be 10 factorial over 10 minus 6 factorial, which is 10 factorial over 4 factorial.
So when the numbers be 1 times, 2 times, 3 times, 4, and then
They would cancel.
10. Oh, I see. You're right.
Because if we expand this, and this is...
Well, you could reduce it. Can you reduce factorials to be like 8 over 2?
No,
Or
not
5
in
over
that
2?
not in that way.
Okay.
Because this simplifies to 10,
Oh, right, because
9,
you're multiplying. So.
8, 7, 6, 5, 4, 3, 2, 1.
And that's 4, 3, 2, 1.
Right.
Oh, okay, I see.
4, what decimal? 2, 1, and then this cancels.
Yeah.
So if we were thinking about like how to do this the old-fashioned way by hand, we'd end up with this.
Mm-hmm.
If we write it as a factorial and simplify it, we still end up with the same thing. Or we can just plug it into our calculator. It's a lot faster.
Yeah.
Yeah, and you get the same answer.
Yeah. Do you prefer me to do it? I might do it just to like be able to get it for the first section like this, but.
Yeah, either way, we're gonna, in just a few minutes after we get these concepts a little bit more solidified, we're gonna take this concept and apply it to something different.
Okay.
So, okay. So, when you have...
I like the chair. It's like,
Thank you.
extra fancy.
Okay, so any other questions about this? Can I erase those?
Yeah.
Okay.
Not the picture though. Not done looking at the picture.
Okay.
A masterpiece.
Thank you.
I'm kind of stuck on this.
Okay,
You
what do you
said
need?
make system of equations, right?
Yes.
So I plugged in here and here, and then simplified both of them.
Okay.
So those are proper simplification, right?
Why do you have d times a plus 1, or a sub 1?
Because oh, what? I don't know.
Yeah, it just
Yeah,
simplifies
no.
to 16d on that side. Yeah. So now,
So
oh, you should plug in the actual number. If you're using 16 for n, or 17 for n,
there.
what is a sub 17? It
What
tells
do you mean? What?
This is number 33.
No, a sub 5 equals 17.
So n is 5, not 17. Because n is like, what number are you using?
Right.
The 5th number. And that equals 17.
And that would be, what, 15?
Mm-hmm.
Right. Okay.
So it equals 17. When you're using 5
Okay.
for n, you get 17 as your answer.
These two are 5, or 17.
17.
And then
And you need to change
these two
this.
are 77, right?
Right.
Yeah.
And we need to change this and this.
Yeah. And then we can just have these two equal each other, right?
No, because 17 and 77 aren't equal.
Oh, right.
So you could solve one of them for a sub 1 and plug that into the other. Or you could multiply
How
one
can
of
we
them.
solve it for a sub 1 if we
Just
still have
move-
d in the equation?
Just move d to the other side. And then it'll say a sub 1 equals.
Oh, okay. Yeah, so just subtract this whole thing here.
Yeah, just 14d over here.
Okay. So it'd be like... for the actual...
Okay, yeah, you could do that. And then solve for d. And then once you know d, plug that back in to find a sub 1. And then you can rewrite your formula with a sub 1.
We can't solve for d, though, without it canceling itself out, right?
Yeah, you can.
Because we'd either have to add or subtract d from either side, and then...
Do it. That'll work.
Okay. Oh, right, because we've got multiple... I'm so bad at this.
Those ones were not fun.
And then that would be 50?
60.
60.
There you go.
Okay, and then we can plug in for this in the normal equation.
Not yet. You still need a sub 1. So you're going to have to use either this one or this one. Plug in your d and find a sub 1.
Okay.
All right. So now we're going to talk about a very specific a very specific type of problem using permutations. Okay. So
It looks pretty specific.
you have the letters Mississippi.
I might exercise BPI. Why? I spell it like this.
And the
You
question
don't know.
is,
Why?
how many different ways can you arrange the letters? So this is like a permutation, except we have repeats.
Right.
So when that happens, there's no difference between this S, this S, this S, and this S. They're the same letter. So we have to do something additional to figure out how many different arrangements there are. So what we do is we count out the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. So there are 1, 2, 3, 4 I's. There are 1, 2, 3, 4 S's. There are 2 P's. And just for being thorough's sake, 1 M. Okay. So the way that we solve this problem, we do 11 factorial over 4 factorial times 4 factorial times 2 factorial. Should also do times 1 factorial, but that's just 1. So,
Times 1.
yeah. Okay. And then you can just plug that into your calculator. Factorial is under the same menu as combinations and permutations. Does that make sense?
Oh my gosh, I didn't even do the right problem. I did 33 instead of 35.
Didn't you need to do both?
No, it's
Oh, yeah, I was trying to
15
do
through
nice.
29
every other
odd,
odd.
31, 35.
Every once in a while I do that, just like.
That's okay. Just go on to 37 or 35 and
45.
whatever would have been next. Okay, so say we wanted to find how many different ways there are to arrange the letters in the word alligator.
Mm-hmm.
So
Sorry, continue.
what number would go on the top?
The total.
How many are there?
Total letters, so 1, 2, 3, 4, 5, 6, 7, 9.
Okay, and what goes on the bottom?
The number of letters for each letter. So A would be 2 factorial, and then L would be 2 factorial, I would be 1 factorial, G 1 factorial, T 1 factorial, R factorial. So
There you go. So it's just 9 factorial over 2 factorial times 2 factorial.
Mhm.
And then you just plug that into your calculator.
Okay.
Very good. Does that make sense?
Yes.
Okay. So I think that's so. Now we're going to talk about. I want to give you lots of time to start your homework so that I can answer any questions you might have.
Okay.
Something that's called the binomial theorem. So the binomial theorem is really cool. Have you ever heard of Pascal's triangle?
I don't think so.
So,
Okay, I have.
oh, you think you have? I thought you were just about to say, I have a question.
No.
So, okay.
I was going to say.
So Pascal's triangle is like this. Starts off with a big number 1.
Okay.
And then 1.
Oh,
and
wait. I think. Continue.
You
1
showed us
always
this
line
earlier in the
the
year.
whole thing.
Okay.
So then this becomes 2.
Mm-hmm.
And this is 1.
Mm-hmm.
So then 1 is line it. So then 1 plus 2, 3. 2 plus 1, 3. 1.
Okay.
1. 3 plus 1 is 4. 3 plus 3 is 6. 4, 1.
So it's just an artsy way of adding.
We're adding all the previous 2 terms that were
Right.
with it. So then 1, 5, 10, 10, 5, and 1. Now, while this is interesting, it's actually useful.
Okay.
These numbers just so happen to be the coefficients of binomials expanded out. So binomial, remember, is 2 terms, like in a polynomial.
Mm-hmm.
And if we have it raised to some power, so let's cube it. Okay? Or let's square it first, just to show what we're talking about is happening. So that's a plus b times a plus b.
Mm-hmm.
So if we FOIL it out, we get a times a.
A squared plus 2ab plus b squared.
Exactly. What are the coefficients here? What's the coefficient?
Wait, a, right? Or would it be 2?
It's 1.
Oh.
It's the number in front of it.
Oh.
So 1,
2, and then
1, 2, 1.
Oh, okay. So then.
So you start counting here. This is 1.
Mm-hmm.
And what are the coefficients of a plus 1 raised to the first power? Simplifies to this. What's the coefficient?
1 and 1. So where do you start counting those? So is it
Start
1,
counting
1,
here.
2, 1, 1, 3,
Right.
2?
This you start with 0. What's a
Uh-huh.
plus b raised to the 0 power?
0.
No.
1.
1, exactly.
Okay.
Raised to the first power, those are the coefficients. Raised to the second power, those are the coefficients. Third, fourth, fifth. Does that make sense?
Mhm.
Okay. So, the only other thing you need to remember is what's happening to the exponents. So, what ends up happening to the exponents, say we have a plus b cubed. Your first number, we're going to take the coefficient from there, it's just 1. A starts off with this number. B starts off with 0. And then for each term, our next coefficient is going to be 3. A goes down 1, so it was 3, now it's 2. B goes up 1. And every single term, the exponents will add up to this number right here.
Oh. Okay.
And then our next term, our coefficients are next number, so it's 3.
Wait. Oh, it's 3.
1, 3, 3, 1.
Oh, I see. So it goes across.
Mm-hmm. Yes.
So it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1.
Yes.
4. Okay. So then it would be 3ab to the third. To the third.
Because they have to
Oh,
add up.
because that's a 1.
Right.
I can see right there.
Yes.
Okay.
And then our last term, our next coefficient is just 1. A would be to the 0. Anything to the 0 is 1, so I'm just going to leave it off.
Mhm.
So b cubed.
Oh, whoa. Okay.
Does this make sense?
Yeah.
So let's
Can I
do...
see the picture real quick?
Yes, of course. And it's also recorded.
Oh, yeah.
I think I need to erase this.
That's so sad.
Okay, so say goodbye. We have a recording of it.
Goodbye to Paris.
I feel like that's a song. Say goodbye to Paris.
Probably.
Okay. So,
Be a sad flowers.
let's try this one. I don't ever use this one. Okay. So, now let's do a harder one. Let's do 2x plus 3 to the 4th.
Okay.
So, we're going to 4. 1, 2, 3, 4. Here are our coefficients.
Mhm.
Okay? So my first term is going to have a coefficient of 1. I'm going to be very thorough, just because you don't have to be that thorough when you're doing the work. Okay. Then our first term is 2x to the 4th. And then the next one is 3 to the 0. So moving on again. So our next coefficient is 4. 4. 2x.
To the 3 and 3
Yes.
to the 1.
Exactly.
Okay, and then 6, 2x to the 2, 3 to the 2.
Exactly. Very, very good.
4, 2x to the 1. 3 to the 3. And then 1, 2x to 0. Wait, yeah, 0, 3 to the...
Right. Very good.
It's like...
It's just a pattern.
yeah.
There's a lot
I'm just
going
afraid I'm
on,
gonna forget it.
but the pattern itself is very simple.
Yeah.
Okay. And then we're just going to go through and simplify everything.
Right.
1 times anything is itself.
Yeah.
2 to the 4th is 16. X to the 4th is x to the 4th.
And 3 and 0 is 1. So.
Exactly. Here, 2 cubed is 8. Times 4 is 32.
Mm-hmm.
Times 3 is 96. And x is cubed. Plus 2 squared is 4.
Mhm.
Times 6 is 24. And then 3 squared is 9. So 24 times 9 is 226.
Whoa.
X squared. Okay? 2 to the first is just 2. Times 4 is 8. 3 cubed is 27. So 8 times 27,
216.
thank you.
X.
X. And then lastly, 1 is just 1. Anything to the 0 is just 1. So we have 3 to the 4th, which is 81. There you go.
Okay.
So no more having to FOIL this out.
Yay!
You can just use...
Could have done that the entire year.
But this is only when you have a binomial raised to a power. This does not work if you have a trinomial raised to a power. So you can't do this. That won't work.
Oh, I see. Okay.
Only if there are two terms and only if it's raised to a power. This also won't work if you have something like this.
Okay.
You have to just have a binomial raised to the nth. Okay. So this feels okay so far?
Yeah. I just hope I'm gonna remember it because I can totally do it right now.
So there's something cool that's also true about this. If you want to find those coefficients, you could go through and you could write out Pascal's triangle, just doing adding one step at a time, one row at a time, until whatever power you get to. What if you get a really high power? What if you want to do? What if the question is x plus y to the 15th?
Mm-hmm.
You'd have to draw out a lot of rows, right? And that would take a lot of time because it's always going to be one more term than whatever row it is.
Mm-hmm.
This is the row 2 because it's the exponent for 2 and there's 3 terms. So you're going to have 16 terms in that bottom row.
Right.
That's big. That's a lot of work. There's a different way to find the coefficients. So Pascal's triangle gives us all the coefficients. It doesn't give us the exponents.
Mm-hmm.
The exponents are really easy to figure out because the first term counts down 1 from whatever this number is each
Mm-hmm.
time. The second term counts up 1 from 0 each time. Bless you. So the other way to find the coefficients is using combinations.
Oh.
Which is this.
Okay.
That we just learned.
Oof. Okay.
So, these two numbers right here will always be the first, so this one, 15 is n. So 15, choose, and then you're going to do right here, it's going to be the exponent of the second term. So the first time, the exponent is 0. And then you've got x to the 15th, y to the 0. Your second term, to find the coefficient,
B15C1.
yes, very good. And then x to the,
And we're adding this. Wait, and then
because x was to the 15th, so now it's to the 14th. Y was to the 0, so now it's to the 1st.
okay.
So what comes next?
15C to the 2.
Yes.
And it would be x to the 13th, y to the 2.
Yes.
Mr. Peterson,
Yes.
are they just trying to mess with you on this one? With the parentheses? That doesn't actually mean anything, does it?
It just means it's a -5
Well, I mean, the -10 isn't in parentheses.
because it doesn't have a plus sign in front of it.
Oh, plus -5.
Yes.
Oh, right. Okay. Thank you.
Right, so what would that look like? How do you do that on the calculator?
We don't need to keep expanding this, but I hope you get the pattern. So, go type in the number 15, and go to the math button, scroll over to probability, scroll down to the NCR, type in 0,
Okay.
and you get 1. What a big surprise! That's the first number in every row.
Oh,
of
I see.
Pascal's
So
triangle.
that's right. We're finding numbers. We're not finding the actual. Because I was like, but how does that work with the terms? Okay.
This right here only tells you the coefficients.
Okay.
And there are 2 different ways to find it, and they will work exactly the same way every single time.
Okay. Okay, that makes sense.
Now, say that you want to find a specific term, okay? Say, I'm going to erase this, is that okay?
Yep.
Say they give you 3x minus 4 to the 10th, and they want you to find what is the 6th term.
Okay.
So what is the exponent going to be of the x for the 6th term?
Oh, you put minus 4. Whoops. Okay, sorry.
It's okay.
And then. Could you just like skip to the 6th one on the
No,
numbers?
because the coefficients are going to be from the 10th row.
Yeah.
So to find just the exponent for the x term. Okay. So for the first term, what's x's exponent?
3. Or 10.
10.
Exponent coefficient. Okay.
So for the first term, it's 10.
Uh-huh.
What is it for the second term?
9.
Third,
8.
fourth.
7. 6. 5.
So its exponent is 5.
Okay.
So once we know that, we know that it's going to be 3x to the 5th. So what is the exponent of negative 4 going to be?
So it would be, 3x to the 5, and then minus 4 to the, it would just be 10. It would be 5.
Right, because they have to add up to this number.
Right.
And then what to find my coefficient, the combination formula, how do I set that up? What C what?
Sorry, what?
So I've got my big C here, right?
Uh-huh.
What two numbers go here?
Oh, okay. It would be the total number of exponents, or
Well, so what goes first?
5? Or 10? Okay.
And what goes right here?
It would be the number of exponents in the y
Right.
spot. So
So
5.
5. So now we're just going to simplify this. So on your calculator, you're going to type in 10C5
And it's 252.
Right. Now you're going to type in, remember the exponent applies to both terms in here.
Uh-huh.
So that's going to simplify to 3 to the 5th times x to the 5th.
3. Okay. Yeah.
Okay. So 3 to the 5th is 243.
Mm-hmm.
Times x to the 5th.
So why are we multiplying all them together? Why are we multiplying all them?
Because they're all just a single term.
Oh, right.
Okay. And then
Wait, so 252 is what?
the 10C5. That's the coefficient. If these numbers were just like ones, then the coefficient would just be 252.
Okay,
But
so
because they're not, we need to combine them with whatever they are. Okay. Just walk. now we still have the negative 4 to the 5th. So that simplifies if you just do negative 4 to the 5th in your calculator. Negative 1024. And notice that when this is a subtraction in the binomial, the negative goes with the y term. Okay. So now we're just going to simplify by collecting all of our like terms. 252 times 243 times negative 1024 negative 627.05664 x to the 5th.
Wow, that's a big number. Okay.
Can you imagine having to do that all by hand using Pascal's triangle?
Oh,
Just to find one term.
Yeah.
That would take a very long time.
A very long time.
So knowing this formula is very helpful.
Yeah.
So if they tell you what is the coefficient for the x cubed term? So coefficient for x cubed. Okay. So if we know the exponent for the x already, we don't even have to do any of the counting thing. Try to figure it out.
All right. We just need to. Right.
So how do I set it up? You know you're going to have NCR first. So what number is for n?
It would be 10. And then x to the 3rd, that would be, so 7.
Yes! Good!
Okay.
And then what?
And then, okay, so that would be, that would be the coefficient.
Right.
And then it would be times 3x to the 3rd.
Good.
And then negative 4 to the 7.
Yes.
Okay.
That's it.
And then you just multiply that.
Yeah, just type it into your calculator.
Okay.
You got it!
Yay! I'm going to take a picture.
And that's everything, by the way.
I
Okay.
got part A of
Cool.
this. I need help on part
So,
B.
let me stop recording.